Hey everyone, and welcome back from our spring break. We are still in the quadrilaterals unit, and we are going to be finishing it up this week and finishing the week with a unit test as well. So just to kind of recap on what we've done, we've looked at the different quadrilateral shapes, we've looked at how to classify them, we've looked at their individual properties, and then how to solve questions based on those properties. We threw a couple of proofs in there as well. And then right after our quiz, so you guys should have taken a quiz, right after that quiz, we also started looking at quadrilaterals on the coordinate plane and how you might prove different properties of different quadrilaterals. Now, one thing I'm noticing from that is that some of you are not proving enough properties to guarantee that it is a particular shape. So an example I would give you is you've got 4 points and you were asked to prove that the shape is a rectangle. Some of you are doing a great job. You're saying, okay, I can show you that the opposite sides have slopes that are equal. So opposite slopes are equal, which is a property of a rectangle. So you're not wrong, but that is only enough to prove that the shape is in fact a parallelogram. It does not prove that it is also a rectangle. You would also need to say that the adjacent sides were perpendicular, or that you looked at the diagonals and you did the distance for diagonals and they were actually congruent. So something else that is unique to rectangles that would be like, this is what the shape has to be. There's no other option. So just think about that as you're moving forward, especially if you think that may have been you. Go back through the exercise we did and try it again and make sure that you're looking at it and saying, okay, this has to be a rectangle. There's no other shape it can be, or square, rhombus, whatever it was, and just double check yourself. Okay, so moving forward, today we're going to look at inscribed quadrilateral theorem and how you solve questions using inscribed quadrilaterals. To inscribe something means to put it inside of a circle, so where the points of the shape are on the outside of the circle. Trapezoid Midsegment Theorem is our other theorem we're going to look at today. So we're kind of getting towards the end of the unit where we're piecemealing a couple of different things about quadrilaterals together that are important things, but they're just not enough to have a lesson on their own. So we're going to have a lesson on this. Tomorrow is a practice day, and I will also post the next lesson as well tomorrow in case you want to get a head start. And then Thursday is going to be a practice unit test day, and then Friday is going to be your unit test day. So I need you to make sure that you are scheduling yourself to turn up on Friday and take a unit test. So that is only going to be open for one day. So please make sure that you are scheduling yourself at least an hour to open up, Schoology on Friday, take the unit test. So get that on your calendar, make sure you're ready to go with that. All right, essential questions for today. What do I know about the angles of an inscribed quadrilateral? So it gives you a hint there's something special about the angles when we inscribe one inside of a circle. And then what is special about a trapezoid's midsegment? So what is midsegment, and then what is special about it? All right, so warm up to kind of get those gears going again. We've had a couple of days off. PQRS is a parallelogram. If angle P is 10x plus 12 and angle R is 6x plus 26, find the value of x and the measure of angle Q. I would like you to pause the video now and try and solve this. When you come back, I will run through how to solve it. Okay, so the key to this one is remembering that the order in which you are given the shape, so PQRS, is important. That's the order in which the points connect to each other. So we're going to do a quick sketch here. We've got a parallelogram, and it doesn't matter where you put the points, and I'll show you why in a second. So PQRS. What matters is that they do go in order, so they connect to each other based on how we were given the question itself. So if we look at angles P and angle R, P and R, no matter where I place them on the parallelogram, are going to be opposite each other. So now you're in your head, you're like, okay, parallelogram, what do we know about opposite angles? And what we know is that opposite angles are congruent. So adjacent angle, supplementary, opposite angles congruent. So that means those two values are going to be equal to one another. So, very easy. We get to say 6x plus 26 is equal to 10x plus 12, and now we got to go solve it. So subtract 6x from both sides, subtract 12 from both sides. 26 minus 12 is 14, and 10 10 minus 6 is 4x. So then, we're going to have to pull out a calculator probably for this one, unless you can do this off the top of your head, which kudos to you if you can. So 14 divided by 4, we get 3.5 is equal to x. So dividing both sides by 4, 3.5 is x. Now that's not the question, well, it's not the end of the question. We have a second part as well, and that is angle Q. So angle Q is not one of the ones we were given, but we know angle R and angle Q are going to be supplementary because they are same side interior angles between two parallel lines. So, let's figure out what angle R is. So we got 6 times 3.5 and plus 26. So that's going to be angle R. 6 times 3.5 is going to be 21. Double checking myself. Yes, 21. So 21 plus 26 is 47 degrees. So that means angle R is 47 degrees, and angle Q is going to be supplementary to it. So angle Q is going to be 180 degrees minus 47. So the angle Q plus 47 should be 180. So that will be 33 degrees. 133. So there's our two answers. X is 3.5 and angle Q was 133 degrees. If you made a mistake, assess where the mistake was made, why it was made, and then basically try not to make the same mistake again. All right, here is a second warm-up question for you. Given the points A and B, identify the locations of points C and D so that ABCD forms a square. So you're going to find the missing 2 points C and D to make this a square. And the other hint is that C is on the y-axis. So I want you to pause it, try and figure this out. Now, graph paper is really helpful here, or draw your own axes, put it on paper and look at it, and then try and determine where are points C and D. Okay, so just to show you what this looks like, here's points A and B, and we need to figure out where are C and D. So there are two options here when it comes to drawing the square, and that's the part that a lot of people don't realize, is that when you're only given one side of the square, there's two ways you could go. You could go A to B, so I'm going to try and draw this with a straight line. Close enough. A to B. C could be up this way, or it could be down this way. So we could have like a C down here and a C up here. We don't know which way this is supposed to go. And then that would mean that our two squares are roughly square one, square two. So there's two options, and then we need to figure out, okay, well, which one are we actually looking for? So C is on the y-axis. This C is going nowhere near the y-axis. Remember, the y-axis is the one that goes straight up down. So that tells me we're looking for square number 2. We need to go down, and I just probably have done a bad job of guesstimating where my C should be. So I'm going to try and get back to blank again. All right, so we need to figure out where should point C be. So let's connect A to B again. Now, if we look at this, this one was down 1 unit and over 3. So we can use that because we know when you have a square, all 4 sides are the same and all the angles are 90 degrees. So again, using your properties to figure out where should these things be going. So that means that if I have the slope of one side, so say if this was AB at the top of my square, then BC should be perpendicular to it. And the slopes should also be perpendicular. So that is A over B is perpendicular to minus B over A. So the slope of AB, rise over run, it's going down 1 and over 3 as we go from left to right. The perpendicular slope to that, we flip it and change the sign. So that would be minus 3 over negative 1, which would simplify to be positive 3 over positive 1. So negative divided by negative becomes positive. So that means that point C is going to have a slope of positive 3. So that means it's going over 1 and up 3. So this is where it would be if C was above the shape. But since we're going down, we need to go from right to left. So what we're actually going to do is we're going to reverse it. We're going to use this double negative slope. So that would mean that we were going down 3 and left 1. So if you're making it negative, you're just going the opposite direction. So we're going to go down 3. So 1, 2, 3, and left 1. And look at that. We are on the y-axis, which is exactly where we're supposed to be. So that means the coordinate of C is 0, negative 1. Okay, one thing to look out for on any printed test you do, it's so easy for when a picture gets pasted onto a Word document that the picture just gets skewed in some way. So it gets made a little taller, a little wider, shrinks in some way. And if the boxes are not perfectly square, so if these are not perfect squares, like they're rectangles essentially, getting like a protractor out and measuring 90 degrees won't necessarily work. Using a compass won't necessarily work because technically the numbers are different. Like we are looking for a coordinate answer, not a construction. All right, to find point D, we do the exact same thing, but from point A. So we go over 1 and down 3. So when I complete my shape, there is A, B, C, D, that is a square. And the coordinate of D is -3, 0. Now in a benchmark or sometimes in a unit test, I will ask you, what property of a square did you use to tell you that? So if you think back to the thinking that I went through, it was all sides are congruent and adjacent sides are perpendicular. All right, inscribed quadrilaterals theorem. So inscribed quadrilateral just means that we have a four-sided figure that is inside of a circle. So its corners, its vertices are on the circumference of a circle, and then it's connected in such a way that it makes a quadrilateral. The theorem is that the opposite angles are going to be supplementary. So all four angles still add up to 360, it's still a quadrilateral, but that the opposite angles will be supplementary if all four corners are on the circumference of a circle. Now, we will really dig into this theorem when we get to our circles unit. For now, we're going to just kind of say, okay, this is a cool thing that's popped up. We're going to use it. And then when we get to circles, we're going to come back to it and we're going to really dig into, well, why is this? Why does this work? I don't want to go too deep in the weeds with the circles unit because we will get there eventually. So just in the picture example, angle A and angle D would add up to 180, angle B and angle E would add up to 180. Okay, so here's our practice. We got four-sided figure inside of a circle, the four angles are labeled, and we're being asked to solve for X and Y. So let's start with, let's try and make a plan here. If we look at the angle 105, we can solve for X. That's a nice easy one. So 105 and 7x minus 2 are the opposite angles. Remember, opposite angles will not be adjacent, so they will be opposite each other. They may not be visually like directly across the circle from each other, but they skip an angle, so every other angle is the opposite angle. So that means 105 degrees plus 7x minus 2 is equal to 180 degrees. So 105 minus 102 is 103. And then subtract the 103 from both sides. So 7x is equal to 77, which means x is 11. All right, for the other one, both angles have y in them. So, this angle and this one are supplementary, and they both have y. So we're just going to set it up, same thing, as an equation and solve it. So 4y plus 14 plus 7y plus 1 is equal to 180. 4y plus 7y is 11y. 14 plus 1 is 15. Common mistake people make, if they're on the same side of the equal sign, you just simply combine like terms. So the 4y and 7y, there's no like subtracting from both sides. They're both on the left side of the equation. You can just combine your like terms. Same with the 14 and the 1. And then equals 180. From here, now we subtract 15 from both sides. That's our subtraction property of equality. So we take the same thing away from both sides. The equation stays balanced. And 11y is equal to 180 minus 15. So it's 165. And then divide both sides by 11. And y is 15. So we have x is 11, y is 15. All right, so in Schoology, you will find this worksheet attached. You are going to do 4 questions, and then the answer key is also included in that PDF, so you can just check and see, okay, did I get X right? Did I get Y right? Not collecting this from you. This is just for you. If you have questions about it, please post it in the discussion for today's class. So classmates can come and help you out. Miriam will be there. I will be there. Mr. Livergood will potentially be checking in as well. So you will get support if you have questions. Please do not sit on your questions and feel like you are stuck alone at home. Share what they are. We are all here to help each other. So somebody will know what's going on and they will be able to explain to you what is going on. Use the video option, use the picture option, whatever it is. Make sure you reference question numbers, that sort of thing. Okay, the second theorem for today is the trapezoid midsegment theorem. So a midsegment is when you take 2 midpoints and you connect them. So we have midsegments in triangles, which will come up in the next unit. So that will be if you have a triangle and you find the midpoint of any 2 sides and connect them, there's going to be something special about that. Or if you find all 3 midpoints and connect them to each other, we end up with a very special situation again. That is coming up next unit. So don't worry about that for now. We are focusing on trapezoids. So in any trapezoid, doesn't have to be isosceles, even though the picture is isosceles, if you find the midpoint, so if this piece and this piece are equal, and this one and this one are congruent, then EF would be a midsegment. So we know that since AE and ED are the same, that point E must be a midpoint. BF and FC are the same, so F must be a midpoint. We can connect those two, we get a midsegment. Now what is special about the midsegment? The midsegment is the average of the 2 sides that it is also parallel to. So it ends up being parallel to the top and the bottom. So remember, in a trapezoid, we have a pair of parallel sides. So it ends up being parallel to those 2 sides and the average of their lengths. How do you find average? You add them up and you divide by 2. Or you do a half times the sum of the 2 sides. So here's our practice example. If you feel like you got it, pause the video, solve it yourself. If you're still like scratching your head and wondering what am I talking about, hang out here, go through this with us. So pause again the video and sketch the question out, take notes, and follow through with us. Okay, so in this one, we know the midsegment is 20. AB is 2x minus 4, and DC is x plus 14. Our formula was that if I take AB, so the top, add it to the bottom, and then divide the answer by 2, so I take the average of the 2 of those, it will be equal to the midsegment EF. Now all I'm going to do here is I'm going to substitute in the values I have. So AB is 2x minus 4 plus DC, which is x plus 14, all over 2 is equal to 20. And now it's, again, another math problem. I would get rid of the denominator first. It's kind of annoying to have it there. So if we multiply both sides of the equation by 2, 2 divided by 2 simplifies to be 1, so that nullifies the dividing by 2. And we get 40 on the right-hand side. So we're going to have 2x minus 4 plus x plus 14 is equal to 40. And then now we can combine like terms. So 2x plus 1x is 3x. Minus 4 plus 14 is 10 is equal to 40. Subtract that 10 from both sides. 3x equals 30. X is equal to 10. And just make sure you check the question. We were in fact asked to solve for x in this case, but sometimes you can be asked, well, what's the length of CD? Like apply x and solve. Okay, your turn again. This one is a complete trapezoid review worksheet. Came across this online. I was like, yes, this has the mid-segment stuff, but also reviews some of the angle stuff that was coming up in trapezoid. So it doesn't hurt to go back and view that again. With this one, you're going to have 28 questions. I want you to complete all the questions. And then there's a Google form where you can put your answers in and check to see how you did. Now this one is graded, so take your time. Double check your work and then input your answers. You get one shot at inputting on the Google form, and then I will take that grade as your grade for this particular class. So you have tomorrow. So tomorrow is Wednesday. You have Thursday and Friday to get this turned in. I recommend obviously doing it before you take the unit test and ideally before you even take the practice test. So you should be aiming to do this on Tuesday and maybe a little bit of Wednesday as well, depending on how long it takes you. Most of the questions shouldn't take you that long to do. There is 28, so you'll get lots of practice on this one. And when you're done, turn in the Google form, get your grade. And if you've made mistakes, so if something's wrong, that's one where you go back and check and see, can you find the error, or you post on the class discussion, say, hey, I got this question wrong. Can anyone walk me through what you did to get the right answer? And let your classmates help you out. That's all we're going to cover for today. You've got a little bit of practice work to do, so I'm going to let you have time to work on that. I'm going to try and get your next lesson up as well, so you can kind of front load the week if you want, and make sure you ask questions if you have them. So essential questions for today. What do I know about the angles of an inscribed quadrilateral? Well, they are supplementary. So the opposite angles are supplementary. And then what's special about a trapezoid's midsegment? The midsegment of a trapezoid is parallel to the other two parallel sides, and it is the average of their lengths. So the parallel thing could be important. Remember, like we could start talking about angles on a midsegment as well. It creates a whole new parallel line that we can have a transversal going through. And then we've also got this average of the length, so being able to solve for the average length. Writing out the formula and then subbing in the information you know is a good way to go about doing that. So for yourself, you need to work on the two worksheets. So you have the Inscribed Quadrilateral one, answer keys provided, and then the Trapezoid review worksheet where you're going to submit your answers on a Google form. All right, that's it for today, guys. I will talk to you tomorrow.